Hello, my name is Aurelio Garcia Ribeiro. I'm with the Java SE product management team here at Oracle, and we're announcing that Java SE subscription customers are now entitled to use GraalVM Enterprise Edition at no additional cost. We hope this will reduce the barrier to use this innovative technology, deliver a performance boost to application developers, and help improve the performance of microservices and cloud-native Java applications. In 2018, Oracle introduced the Java SE subscription, making it simpler and more affordable for companies everywhere to use Java for powering their businesses with the backing of Oracle, the steward and main contributor to the Java platform. Users running on Oracle Cloud receive the benefits of the Java SE subscription at no additional charge. Oracle makes available, at no cost and under an open source license, OpenJDK binaries for the latest version of Java. Additionally, Java SE subscribers have access to our global support services available 24/7 with engineers that have over 15 years of experience with the Java platform. You also receive updates for older versions of the JDK, so you can continue running your programs on those versions for a very long time, or you can update at your leisure. You can also get access to tools that simplify managing Java at a very large scale, and receive bug fixes directly from the main contributors of the platform. Qualified customers will also be invited to our Java Success program with additional perks. Now, we're adding to this list access to GraalVM Enterprise, which will offer a high-performance, just-in-time compiler and the option of using ahead-of-time compilation to package your applications in a format optimized for faster startup and low memory usage. Oracle continues to invest in the future of the Java platform. These are some of the projects that will make Java better in the medium to long term. Work on Project Amber will reduce the verbosity of the Java language while keeping the code easy to read, to understand, and to maintain. Leiden will reduce the startup time of Java applications and the memory needed to run them, similar to what we're offering today with GraalVM that my colleague Sean will cover in a few minutes. Project Loom will provide Java VM features and APIs for the implementation of lightweight user mode threads to make writing multi-threaded code easier. Panama will make it easier to interact with non-Java APIs, which will simplify using many C libraries, like the ones widely used for machine learning and artificial intelligence, without the need of somebody maintaining a Java wrapper. Valhalla will allow using memory more efficiently, giving us the flexibility that we have with Java classes, but with the performance and memory usage of primitives. And CGC has already delivered a low-latency garbage collector capable of handling extremely large heaps. The project will continue improving the performance of this new garbage collector. Now, it is not sufficient to just keep the technology going forward. Oracle is also deeply committed to fostering a healthy Java community with programs to help the next generation of Java developers benefit from one of the largest communities in the world, and to make it easier for experienced developers to keep connected and informed on the rapid advances of this platform. We offer resources to independent Java user groups, students, and professionals across the world. One such effort, the GraalVM project, allowed us to add GraalVM Enterprise Edition to our offering. Now, to tell you more about GraalVM, I'd like to welcome Sean Smith, Product Manager for GraalVM.
Thanks, Aurelio. Okay, so I'll provide an intro to GraalVM Enterprise in the following slides. Let me start by just sort of pointing out that the core of GraalVM Enterprise is a high-performance optimizing compiler. That's the technology that we've invested a lot of R&D in over the last decade, and which has now sort of come to fruition in the GraalVM product. So the first thing the first application of that compiler technology is a hotspot JIT compiler, or just-in-time compiler, that accelerates Java application performance. So existing applications running on hotspot, but with the Graal compiler, we do some better optimization around application performance and around resource consumption. I'll talk about that in more detail in a moment. The second thing we have with the compiler is ahead-of-time compilation. So taking the same just-in-time compiler technology, but adapting it to produce binaries for macOS, for Linux, for Windows from your Java applications, Java, Kotlin, any other Java or JVM native language. And the final thing that we are main thing we're known for is the ability to run non-JVM languages on the JVM. So taking JavaScript, Python, Ruby, and running them on the JVM with excellent performance, and being able to let those languages interoperate amongst themselves and with Java, so you can combine languages together to build applications. So just to give a demystify what we're talking about, the just-in-time compiler, the Graal compiler, is just plugged into Hotspot. So if you download the Java SC download bundle, you're going to get Hotspot with the C2 JIT compiler. That's a compiler that's an excellent compiler. It's written in C++ originally, or is written in C++. But the Graal compiler has a few years of investment, R&D years of investment in optimizations, and has some additional optimizations that aren't in C2. And we simply plug that into the Hotspot VM and accelerate application performance. So it's a pretty simple technology. The GraalVM Enterprise bundle basically replaces the JIT compiler. You can actually turn off the JIT compiler, or the Graal JIT compiler, and default to G2, or go back to C2, sorry. But it's very easy to try your application workload on either compiler and see what the performance benefits are. So what we see is a number of improvements in a broad range of benchmarks running with the GraalVM compiler. You can see here, this is the Renaissance benchmark. You can go to renaissance.dev for more details. And across a number of workload tests that are designed to emulate what you do in real life, so Spark workloads and so on, right? This isn't a benchmark designed to test how fast we can add integers or execute loops. It's designed to try and be more representative of things that people do in real life. On this benchmark, we see an average of about speed up of 1.55 times. There's a couple of particular benchmarks in here in the suite that are extremely fast. You'll notice those are well, you can't see it here, but those are actually Scala benchmarks. It turns out that Scala, being a high-level language, JVM language, is much more amenable to optimization because they have many more abstractions. So the more abstractions you see, the better the optimization opportunities for the compiler. This is also true for Java. So for modern Java applications using streams, using lambdas, there's more chance for the compiler to go behind the scenes and optimize your code. Older Java workloads where you're more on the metal, you're dealing with basic classes and loops, for loops and so on. It's a little bit harder for the compiler to improve performance, although it will through advanced inlining and that kind of thing. But we see quite a nice performance bump to applications running on GraalVM for Renaissance. For other applications like WebLogic, so it's a much more heavyweight, or it's a larger single application. Internally at Oracle, we've done some benchmarking. We see benchmark performance improvements on, for example, JDBC in this case, up to about 25%. And it varies. So again, it varies on the kind of applications, the kind of code, how old the code is, whether you see much of an improvement or not. Scala, you see on the Scala bench, we're seeing excellent performance. So up to 2.75 times faster on some calculations. So on Scala bench, we're looking really good. And again, we kind of expect to do quite well with Scala. Just to drill into some of the results in Renaissance for Spark in particular, what's really interesting about this benchmark is not so much the performance numbers, but comparative numbers. If you run that same benchmark with different amounts of RAM, you get different performance. And this is, of course, expected. If you give your JVM more resources, it will behave a little bit differently. So in this case, you see here that when we give the OpenJDK and GraalVM 6 gigabytes of RAM, we can get the job done in a certain amount of time, right? It's quite fast on the 6 on the left. If you look over on the right at the 10 gigabyte area, if we give GraalVM and OpenJDK 10 gigabytes, the performance is obviously improved. But the key thing here is that GraalVM can outperform OpenJDK with 6 gigabytes of RAM compared to 10. In other words, same throughput, fewer resources. So if you're deploying application workloads to the cloud, this is the kind of thing you're looking for, right? Can I get my throughput? Can I get my computation done? But can I get it done cheaper by having a virtual machine with less RAM, right? Because you're paying for RAM and CPU typically in the cloud over time. So we have, of course, we use GraalVM ourselves at Oracle. We have the Oracle Cloud Infrastructure, which is a worldwide cloud platform running in multiple data centers globally. The monitoring service was one of the first ones to transition to GraalVM Enterprise by switching basically from JDK 8 to GraalVM Enterprise 8. They saw a 25% reduction in garbage collection time, which led to a 10% improvement in throughput, basically transactions per second. Now, I hadn't mentioned it before, but garbage collection is an interesting result, and the reason is because the Graal compiler is very good at optimizing away unnecessary object allocations. So if you allocate an object in one stack frame or in one method, and that's never used, most compilers can, or never used again outside that method, most compilers, and C2 certainly, will eliminate the allocation of that object in the heap. It'll put it on the stack. If you're dealing with GraalVM, it's much better at sort of looking across multiple methods. The combination of aggressive inlining and a feature called partial escape analysis, we're able to do even more aggressive object elimination. So as a result, less garbage. Less garbage means less time spent for the garbage collector doing work, like consuming CPU, and more time and more CPU for your application. So reducing garbage actually helps on throughput, turns out. Another really interesting result is Dell EMC. As these server vendors bring out new machines, they run spec JBB. We were contacted by Dell and saying that they wanted to publish a benchmark using GraalVM Enterprise because with GraalVM Enterprise Edition, they saw about an 8% improvement in the max JOPS on the spec JBB 2015 benchmark. And to be honest, we were actually surprised to get such a good boost in performance on such an old benchmark. As I mentioned before, the more modern the Java, the better the compiler does because of abstractions. So even in this old code base, we saw a significant improvement that basically the same hardware could do more work with GraalVM as a Java runtime. And Twitter is a participant in the advisory board, the customer advisory board for GraalVM. So we do build GraalVM in open source and open core model. So we have the Enterprise Edition and the Community Edition. The Community Edition doesn't have all the optimizations that are in the Enterprise Edition. So for really optimal performance, you want to use Enterprise, and for obviously support and bug fixes and so on, security patches. But even with the Community Edition, Twitter's seeing a really good improvement in their performance, their throughput. So if you've tweeted today, you've used GraalVM. Your code's running on GraalVM. If you're using Tweet, if you're using News, all these different services they have at Twitter are running on GraalVM. And they're seeing quite a good performance improvement, which leads to savings in terms of servers. So imagine you're Twitter and you're a internet scale company. You've got a lot of servers. 10% fewer servers is a lot of money. So for them, this is a great result. So let's move on to looking at ahead of time compilation. Excuse me. So what GraalVM does is it takes your class files, jar files, whatever, whether, like I said before, whether it's Scala, Kotlin, Clojure, Java, whatever, at that level, at the bytecode level, it's not really relevant. GraalVM can take those jars and and classes and produce self-contained executables. Now, what's really interesting about these executables, well, there's a bunch of things that are interesting. One is they use a lot less memory when they're run, and I'll sort of explain why that is. They start up much faster. Sometimes it's quite shocking how fast they start, and they're also quite small. So rather than having a whole JVM or JRE with hotspot, a bunch of libraries, and so on, you've got a single executable that contains just what you need. Now, the way it does this is the native image utility that comes with GraalVM really is a front end for a process that loads your classes and your jars into hotspot. We do a reachability analysis. So from your main of your application, we're going to walk through the references, find all the code that you need to use in your application, and generate a binary. So ahead of time compile that. So rather than waiting to runtime for just-in-time compiling, we'll do it then and there, and then dump all that code in the appropriate formats, of course, into a binary that runs on different platforms. Now, what's interesting about this binary is that it doesn't contain all the code that it contains all the code you need, but eliminates a lot of code. So classes you don't need are not included. methods you don't need are also not included. In fact, fields that you will use are not included. So you can imagine that you have your typical application that has a bunch of dependencies. You're running on the JDK, which has a bunch of classes. You can use JLink to shrink your application to a smaller size, but you're still going to contain a lot of modules. GraalVM native image goes beyond the module level and cuts out even more. So even within a module, we're going to throw out a lot of what you don't use. So that does tend to lead to quite small applications. Just to give you an idea of what it actually looks like, here you go. So execution time, GraalVM native image applications are sitting in between C and Go. This is a simple hello world. The reason I'm doing hello world here is just to show you the time it takes to boot. The application doesn't really do much, but the time it takes to get up and running and do its simple job of executing hello world. You can see here that compared to a traditional Java application running on Hotspot, it's quite a lot faster. And I'll explain in the next slide why that is. In terms of memory, we're using a lot less memory also. So we're back in the C and Go level. So if you are a user of Java and you want to get into microservices and containerization, and you're thinking, well, the Java platform really isn't designed for this use case. It's designed for running, Spark and WebLogic and other large applications. This isn't the case, right? So with GraalVM native image, you can actually use Java for these environments in which you want to be small and fast. So here's a picture that does kind of illustrate why this application boots fast. The red is CPU usage. So this is that same Hello World application, sort of microservice boot up. You'll see a lot of CPU on the left in the just-in-time compiler, and that's because the compiler has to parse the bytecodes, build in memory representations, start up a JIT compiler, allocate code caches, allocate profile data caches, start profiling your data. And it takes a while for that to get sort of the bootstrap process to go. Now, there have been a number of improvements in the JDK to improve the boot time and to reduce the CPU. This class data sharing, application class data sharing, but these things still will have a similar enough profile to this. And you'll see little red blips on the bottom there on the left. Those are CPU. So we're basically hitting this microservice, the hello world, say hello, say hello, say hello every second. So after a while, the CPU settles down, it's initialized itself, and it's just really running your code. You also see, though, that the memory footprint of the application is around 200 meg in this case. So it's fairly substantial for not doing very much. On the right, you have the same application compiled as a native image or a native executable. You see some CPU because there's still initialization that has to happen when you boot up a native image. You have to start the garbage collector, right? You still have work to do there. There'll be some sockets you're opening up, etc. So things will happen. The CPU, you can see on the bottom, is a little bit busy, but then it goes down to sort of the blip, blip, blip as it gets hit by the test framework. Really different CPU profile, and also the memory usage is much lower. And again, it's because we've eliminated the footprint of a lot of code. You don't load anymore because it's gone. The JIT compiler isn't there; it's gone. All those caches the JIT compiler would allocate, again, profile caches, code caches, they're all gone. So it kind of makes sense why the footprint is significantly smaller. Now, what's good about GraalVM native image is the support from the community. So a lot of the frameworks you're using today are working with native image. So Micronaut is really built from the ground up to be really compatible with native image for ahead of time compilation of applications. Basically because they do all the processing of sort of dependency injection at build time rather than runtime. So we can compile all this code down. Embedded Tomcat, Netty Helidon, Quarkus, of course, and Spring. And the Spring team are working to bring Spring to fully compatible, or it works now, but there's a few rough edges. They have a Spring native project to make it really easy to take your Spring Boot applications and compile them down to native machine code. And if you've been to Spring One conference recently, or the Oracle Java Live conference, you'll have seen Sebastian Deleuze and Andy Clement from the Spring team talking about what they've seen. They're running Spring Pet Clinic as native executable, shaving off 75% of the memory footprint, and the boot time goes from 1.6 seconds or something to like a few hundred milliseconds. So it's a really significant improvement. But this is great if you're a Spring user. There's work coming, there's things coming that'll make your life really easy for building these applications. And all of this, all these frameworks are really designed to containerize for containerization, right? Taking your application and basically deploying it in containers and probably on Kubernetes. So if you're going to cloud, going to containers, native image, and all these frameworks are lined up to try and help. Just a few little numbers here to give you an idea of the performance. My Micronaut colleagues have told me that these numbers are out of date. They'd like me to update them because they don't look as good, but it doesn't really matter what the numbers are. It's the improvement, right? So regardless of which framework you're using, GraalVM native image is making a huge impact on the startup time of these applications. So going from about a second, second and a half down to a few milliseconds, which is really amazing that you can do that with Java. Same thing on memory. You're seeing 4x, 5x, 10x less memory footprint, memory usage for applications. So it's quite significant, regardless of what framework you choose to use. This graph is actually a really interesting way to help you understand the differences in terms of the choices. Like, when do you use ahead-of-time compilation versus just-in-time compilation? These are two choices. This is a choice you've probably never had to worry about before, until now, pretty much. On the left, you see on the top, the red line is a native image application. And this is requests per second that it can handle on this little benchmark we wrote using Apache Bench. So we start up the application and we just run Apache Bench and we pound on this application. You can see that right out of the gate, the native image application is quite performant. It's very consistent performance. It kind of levels out. It's predictable, right? So you know what performance you're going to get. Once you benchmark it, you kind of know what it's going to do. It starts really fast, right? As we saw before from those curves, it will begin processing responses immediately. The JIT compiler, and you'll see here, blue line is GraalVM native image, or sorry, GraalVM with JIT compiler. The green line is OpenJDK. You can see the curve, it gets better, right? So the JIT compilers learn. They learn from running your code, they learn what the hot code paths are, they optimize that code, and then you end up with better performance than you get currently with ahead-of-time compilation. Because basically the ahead-of-time compilation, we make all the decisions at build time and it's frozen. Just-in-time compilation, you can make decisions much, much later and learn from the specific use of that application and tune exactly. So what we are working on is profile guided optimization, and we have some features now in GraalVM native image to help move that red line up. But today you have to kind of decide, do you want fast performance out of the gate, or do you have a long running process where throughput peak throughput is the most important thing ultimately? And if you're in an environment like serverless functions or some short-lived container workload, booting faster is probably more important, so you'd be on the left. If you're running a more heavyweight long-lived service, again, you'd be on the right-hand side. So that's really the GraalVM Enterprise in a nutshell. Our tagline is faster, smarter, leaner. We are making Java applications and other JVM languages run faster just out of the gate. And we have this new feature to compile your applications to run as native executables on various platforms. And this is done through about more than a decade of research and development into compiler optimizations. So there's a lot of technology that's baked into this compiler. And leanness we saw in terms of the memory usage and CPU usage, right? We saw a lot less CPU on that startup. You saw the CPU for native image was really quite low. The memory is lower. We didn't see it so much for the JIT compiler, but it's the same as true. The JIT compiler resource consumption is, again, significantly lower. So as you've heard, we've introduced GraalVM Enterprise with the Oracle Java SE subscription. We've added it, and that gives you access to GraalVM Enterprise if you're a Java SE subscriber. So you can go and download it today, try out native image for microservices and for fast startup, and try the JIT compiler for accelerating your existing Java workloads. And to get started, you can go to oracle.com/GraalVM. There you'll find download links. You'll find all the documentation. You'll find videos about various features, native image, JavaScript execution, all kinds of things on GraalVM, and some frequently asked questions that help answer a few of the questions we may not have answered in this video. So with that, I'll say thanks very much, and Aurelio, I guess we'll say goodbye.